Now we shall study about a new term, that is drift of electrons. Drift of electron. Let us consider the movement of electrons in a conductor. As I mentioned you already, electrons are getting free from the atoms. Then that atoms will become ions. These ions are fixed on its own position. Thus, during the time of electric current, how an electron can travel? Electron is traveling in between the interatomic spaces. On the way, they will always collide with other electrons or the fixed ions present within it. Therefore, its path will be deviated. Consider you are simply running through a road and nobody is there on that road. You can simply run through it. But if there are so many people on that road, your running is not so easy. You may always collide with others. That will restrict your motion. This is happening actually in the case of the electrons which is under motion during the time of electric current. Whenever the electrons are traveling, always its path will be deviated. This is happening even in the absence of electric current. Even if you are not connecting a wire with a battery, electrons are in a state of motion. I mentioned it. In that case also, it can travel in a random motion as in this picture. But the problem is that in such a situation, in the absence of electric current, some electron may travel in one direction, some others may travel in other direction. As a total, there is no total motion. There is no advancing of electrons. But if you are applying an electric field like this, you are applying an electric field, then what can happen? Electric field direction is from positive to negative. Therefore, electrons will be attracted towards that positive. That means electron will flow in the opposite direction of external electric field. Thus, electrons will get a force. Because of that force, the electrons can advance forward. That means here you can see a blue line. This represents the motion of electron, one electron, in the absence of an electric field. That means if it is not connected with a battery. But if you are connecting it with a battery, it will apply a potential difference. As a result, there will be an electric field. The same thing is happening in the case of electron, that is sure, but it can advance much more forward. That means you can see the final position. In the absence of battery, that electron can reach only up to B. But when you are applying an electric field, it is advanced towards B dash. That means while you are applying an electric field, the electrons can advance forward. Electrons can move from one place to another. That's why it can make electric current. But from this example, you can understand that the movement of electron is not so easy as you thought. Always the electrons will undergo lots of collision, and each collision will only help it to reduce its speed. I mentioned in one previous example, while you are running, you gain your speed. On the way, your speed will increase, but suddenly if you are hitting with one person, you will stop for a while. Your speed will become less. Now again you need to start from the beginning. Means you need to increase your speed once again. But on the way you may hit with one another person. Again your speed will decrease. While you are increasing your speed, your kinetic energy also will increase. And while you are hitting with that person, you are transferring your kinetic energy to that person. He may fall. He may thrown off because of your hitting, but your speed will decrease. That is happening. Therefore, electrons will not get a chance to increase its speed to a maximum level. On the way, the speed will decrease continuously because of the collision. Okay. Now you may consider in that metallic wire there are so many particles, like n number of particles are there. If you are considering at a particular instant of time before you are applying an electric field, each electrons have different velocity. Okay, so the velocity of first electron can be represented as v1, second electron may be represented as v2, ith electron can be represented as vi. Okay, and if you are adding all the velocities of all the electrons in the material, v1 plus v2 plus v3 plus v4 plus etc plus vn, that will getting 0, because in the absence of external electric field, before you are applying a battery, electrons will be in a random motion that cannot be considered as a motion. Altogether there will not be a motion, because velocity is also related with the direction. The direction of velocity of one electron, direction of velocity of another electron, all are different. Altogether while you are adding, you will get 0. Okay, like you can consider some water kept in a vessel. That water molecules are always in a state of motion, but you cannot say that there is a flow of water in that vessel as in the case of a river. In case of a river, that water molecules are traveling from one place to another place, maybe lots of kilometers. But in a vessel, the water molecules are in a state of motion, but one molecule is moving in one direction, other may move in another direction. That cannot be considered as a total motion. The same way, if you are adding all the velocities, here you will get 0. That is represented here, summation over I is equal to 1 to n vi, that is equal to 0. Then if you are averaging it, total velocity divided by total number, that is summation over I is equal to 1 to n vi divided by n, that is total velocity divided by total n, that is representing here 1 by n into summation over I is equal to 1 to n vi, that is equal to 0. If you are writing without this 1 by n, you may say the total velocity is 0. Now as we are dividing it with n, we may say it is average velocity. So average velocities of all the electrons before the application of battery or before the application of external electric field will be 0. Now what is happening? We have connected the wire with a cell or a battery. Then that cell can give an electric field to the wire. In the first chapter we studied the relationship between the force and electric field. If there is electric field, a charge came into that electric field will be affected by a force. That force is Coulomb force. How much it is? F is equal to Q into E. That is, here the effective particle is electrons. The charge of an electron is minus E. So instead of Q we may write minus E. Thus F is equal to minus E. Now, and in 9th standard and in the last year you studied, if there is force, there is an acceleration. From Newton's second law of motion, we will get F is equal to ma. So while you are applying an electric field to the wire, electrons will be affected by a force, and because of that the electrons will be accelerated, and that equation is ma, representing the force. Thus Ma is equal to minus EE. Therefore what is A? A is equal to minus EE divided by M. This is written here. That means the acceleration of the electron while it is passing through the conductor when an electric field is applied is minus EE divided by M. Okay, now we already studied about the Newton's equations of motion. By using that equation we may say V is equal to U plus AT. Final velocity is equal to initial velocity plus acceleration to t. And in 11th standard we modified it as V is equal to V0 plus AT. We can make use of that equation here. The previous iteration we got the initial average velocity of all the electron. Vi means this small vi representing the initial velocity of ith electron before the application of external electric field. Now what will be the final velocity, or what will be the velocity at another time after the electric field is applied? That can calculate by using this equation. So this is final velocity, this is initial velocity. Initial velocity is small vi, final velocity is capital Vi. Okay, so this equation is changing in our manner, that is capital Vi is equal to small vi. Capital Vi means final velocity, small vi means initial velocity, minus acceleration. Acceleration we got minus EE divided by M. That's why plus became minus, into t. T means time, here Ti. So what this equation mean? We know the velocity of an ith particle before an electric field is applied. Then after a time Ti, what is the velocity of that particle? That can be calculated by using this equation. In that case, what about the average velocity? This is only for one electron. Okay, and here also Vi is the velocity for one electron, and after that we average it for all the electron, we will get 0 before electric field is applied. Now after the application of external electric field, what will be the average velocity of all the electron? Will it be also 0? Let us see. That can be calculated by using this. That average velocity of all the electrons after the battery is connected to a wire or after the application of an external electric field is known as drift velocity. So we are averaging that value. Vi average, see capital V is final velocity, its average, that is also known as drift velocity. That is equal to, we already have an equation, Vi, capital Vi is small vi minus EE divided by M into Ti. So for averaging this, we need to average each of this term. So average of this capital Vi is equal to average of small vi minus average of this thing. Okay, that is written here. Okay, now initial average velocity is 0. We already got here. This is initial average velocity, that is 0. And the remaining thing is this only needed to average now. And while you are averaging any quantity, the constants can be taken outside. Therefore minus EE divided by M, that is constant. E means charge of an electron, that is common for all the electron. M mass of an electron, that is common for all the electron. And electric field, that also common in this situation, because we may be assume that we are discussing about a uniform electric field. So E is also constant. All these terms can be taken outside, and for averaging it we need to average only the time. This time can be averaged. This average time is represented by a symbol tau. Thus average of this will get a 0 minus E divided by m into tau. That means minus E divided by m into tau. That is the equation for drift velocity. I think you understand. Drift velocity means the average velocities of the electrons after the electric field is applied. You must understand more about this term tau. Tau is the average time interval. Okay, this time is different for different particles, because as per this equation, as per this figure, maybe one electron, maybe first electron is traveling from here. It will travel this much of distance. At that time it will find with one another molecule, so it will undergo collision. What will happen? Up to that time it will get a facility to increase its velocity. But for another electron it may not get that much of luck. Okay, it may not get that much of fortune. That electron may undergo a sudden collision. Can it increase its velocity much? No. That means each of the collision, one collision after that one another collision, the time interval between the successive collision, that is known as tau. The time interval between successive collision is different. As like if you are comparing the lifespan of different persons, some persons may live for 50 years, some may live for 100 years, some may live for 60 years, like that. Similarly, the lifespan, the time is different. Okay, so if one electron will get more time before the next collision, that electron is more lucky, because it will get more chance to increase its speed. Until the next collision, the electron will get a time to increase its speed. For such an electron, its final velocity is high. But for another electron, if its time interval between successive collision is very less, it may not get a sufficient time for increasing its velocity. That's why this velocity, final velocity for individual electrons will be different. We are only calculating the average velocity of these time. So if there are 1 crore of electron, the time interval between successive collision for each of the 1 crore electrons, that will be different. We are averaging it. That is this factor. Anyway, if you are seeing this equation, you can see charge is a constant, 1.6 into 10 raised to minus 19 coulomb. Mass of an electron, that is also constant, and electric field is constant, and again tau, that we are only taking its average, that is a constant. That means all these terms are constant. What does it mean? Drift velocity is also constant. Okay, that is just against our expectation. See, we are discussing about a situation in which a wire is connected with a battery. When wire is connected with a battery, it will get potential difference, and if there is potential difference, there is an electric field, like this. And if there is electric field, there is a force, and if there is force, there is an acceleration. If there is a force, there will be an acceleration. There will be an EMF, electromotive force, acting in each of the electrons. So definitely there should have one acceleration. What is acceleration? Acceleration is the change in velocity. Thus, if there is force, there is an acceleration. So you studied about the effects of force. A force can change the state of motion, force can change the speed, force can change the direction, etc. That means if force is not acting, these things will not happen, that we studied in the first law of motion. An object will continue its state of rest or of uniform motion in a straight line unless it is compelled to change that state by an external unbalanced force. So if force is not acting, the velocity of an object will not change, its direction will not change. But if force is acting, what can happen? Its velocity can change. But that was our expectation. But what happens here? From this equation you understand that even though there is an electric field is applied in this metal, velocity is constant. That constant velocity is known as drift velocity. Okay, actually that drift velocity is very small. Okay, now I think today you got an idea. Whenever electricity is passing through a wire, just after the switch is on, current will pass through it and suddenly the electrons will achieve a constant velocity, and that constant velocity is very less. Actually that electrons can travel only in a very few millimeters. Okay, you may think that electricity can travel very fastly, but actually the electrons are traveling in a very less speed, and that average velocity of all the electrons are known as its drift velocity.